Hello everyone, we are Agami Engineering, primarily a group of structural engineers who deal mostly with buildings and solar structures. Lately, we have been doing a lot more than that, and a key focus of ours has been in computational modeling and engineering. We, among the many options available to us, we have been using a popular one, which most of you know as a 3D modeling tool, Rhino 3D. But if you take like a deep dive into it, you can see how the many tools and plugins that Rhino offers you can be leveraged by engineers to solve a variety of problems. So, ranging from simulations of light and shade to convoluted physics scenarios, there's an entire spectrum of problems that can be solved using Grasshopper, which is the plugin that Rhino offers. And within Grasshopper, then you have so many specialized plugins that allow you to solve all these different kinds of problems. The interface is structured like this. Rhino is the parent environment with a typical 3D modeling space and CAD-like modus operandi. Within this, Grasshopper is a visual programming tool. And in Grasshopper, one has the ability to break a problem down into its constituents by way of parameters. And this process of parameterizing a problem is what makes Grasshopper a very elegant tool to solve problems, the kind which we will be looking at in a bit more detail in our future videos and discussions. So, parameterization, the whole is what Grasshopper is built on. And while we play around with the controls that these parameters offer us on Grasshopper, we are able to view the changes visually simultaneously in the Rhino. This would be better illustrated by an example which Ravi will just show.
Hi, my name is Ravi. We are from Agami Engineering. So we have been using Rhino Grasshopper for some of our projects. So Rhino is like any other 3D software out there like Maya 3D, Acacia and so on. For example, on Rhino you can model toys, building and basically all sort of stuffs that you can see on the screen. What makes Rhino interesting is this plugin Grasshopper. So in Grasshopper we can do wide variety of tasks, for example structure analysis, parametric facade, other parametric modeling and architectural designs. In Grasshopper, there are many inbuilt component and third-party component as well, which can do tasks as simple as dividing a curve to complex environmental analysis. And since we are controlling all our geometrical parameters by using numerical inputs, which in turn is controlled by knobs and sliders, we get more robust control over the whole model, and hence doing multiple iterations becomes much more easier and faster. One such example that we have been working on is layout optimization for solar plants. So basically we have written an algorithm on Grasshopper which takes boundary region, all the no-go areas, dimension of the tables and all the parameters that you will need for the algorithm, and it gives us the final fitted table for the whole region. So for example, if I click on run on this particular algorithm over here, it will give us the final fitted table for the whole region. So you'll be able to see the final fitted table for the whole region on the left side of the Rhino screen. Yeah, so you can see the final table, the final optimum fitted table in the Rhino window. At the same time, it also prints the mounting point of the table and also tags the table in the Rhino window for the convenience. Yeah. So as you have seen, getting the panel layout for a region has become much more faster using parametric tools like Grasshopper.
Hi, this is Nimish here, and I am here to explain to you one more problem that we solved on this Rhino Grasshopper platform. A fairly involved one where we took many months to solve this. So the problem involves finding radiation on ground after it passes through modules. Why on ground? This is in the context of agrivoltaics. This was done for a company which was an associate company where we were interested to know for growing crops on ground how much radiation passes through the modules on the ground. So to find that out, we use the same technology stack of Rhino, Grasshopper, Ladybug tools and some other stuff also. What all we coded into this, we have all the module parameters that are possible. We have the tilt, ground clearance, we have shade net. Shade net is something that is used in the context of agrivoltaics. We have simulation output where it's required at ground, above modules, below modules. We have the meteorology data, like where are you doing the simulation, at what time of the year, what time of the day. Do you want a lot of output parameters that you can control in terms of the kind of graphs that you would need. A tracker module where if it's a fixed module, or can it track the sun. So after running all this, the kind of I'll show you the kind of output that you get. So what you see on the screen here is the radiation analysis on ground for Aurangabad for month 4 without a tracker. So the purpose of showing these two extreme examples, what Ravi told you and what I told you, is to explain to you the depth and the width of problems that can be solved using this platform. So more on these things later as we go more into depth. So yeah, that's it.